Just a quick reminder before we get into the lesson to download the hands-on lab exercises that accompany this complete CCNA course. I'll include the link in the description. Also remember to subscribe and hit the notifications bell so you don't miss any of the lessons in the course. Okay, let's get into it. In this lecture, you'll learn how to do a basic configuration of OSPF on our Cisco routers. So to enable OSPF, the top level command at global config is router OSPF and then a process ID. So you can see an example here, I've said router OSPF 1. Different interfaces on a router can run in different instances or different process IDs of OSPF. And different instances have different link state databases, so they run separately. Only one instance is typically configured on OSPF routers. Multiple process IDs are very rarely used. It's not normal to have different process IDs on the router. The process ID is locally significant, meaning it does not have to match on the neighbor router for them to form an adjacency. You'll see what I mean about that coming up on the next slide. So in the example below, we've got three routers, R1, R2, and R3, with R2 in the middle. On R3, both interfaces have been put in process ID 1. On R2, the left-hand interface is in process ID 2, the right-hand interface is in process 3. And on R1, its left-hand interface is in process 4. R2 will form adjacencies both with R3 and with R1. So even though the process ID is different on the routers, that's a locally significant number. It does not have to match on both sides, so the routers will still form adjacencies. In our example here, on R2, the left-hand and the right-hand interfaces are in two different processes. So they're going to have separate link state databases, and information is not going to be shared between the two sides. So R1 and R3 will not learn routes to each other because both sides are in different process IDs on router 2. The way we would configure this is on R2, we say router OSPF 2 at global config, and then network 10.0.0.0, the wildcard mask 0.0.0.255 area 0. And then for the other interface, we say router OSPF 3 and network 10.0.1.0. Okay, so that's how you can have different processes for OSPF running on the same router. It is absolutely not normal to do that. Very rare that you would see this. I'm just showing you it here so that you can fully understand what the process ID is. What is more normal is where all the routers in your network are all using the same process ID number. So you can see here now on routers R1, R2, and R3, the same topology as before, we've configured OSPF process ID 1 on all interfaces. On R2, we say router OSPF 1, network 10.0.0, and network 10.1.0.0 are both under process 1, and now R1 and R3 will learn routes to each other. Don't worry about the area statement on the end here yet. We're going to cover what areas are and how they work towards the end of this section. Okay, so we configure router OSPF, and then usually we'll use a process ID of 1. The next command to use is the network command. This is pretty much the same as the network command that we had for EIGRP as well. So network, and then the network address, a space, and then the wildcard mask, which is the inverse of the subnet mask, and then specify the area. If you've got a small network, you can just put everything in area 0. Again, we'll cover areas in more detail later on. So network command, it uses a wildcard mask rather than a subnet mask, which is the inverse of the subnet mask. So if your subnet mask was 255.255.0.0, your wildcard mask would be 0.0.255.255. If your subnet mask was 255.255.255.252, your wildcard mask would be 0.0.0.3. To figure out the wildcard mask, just subtract the octets in the subnet mask from 255. Next thing, in EIGRP, if you specify the network statement and you don't include a wildcard mask, it defaults to using the classful wildcard mask. For example, 0.255.255.255 for a class A. In OSPF, it does not default to doing that. You have to enter the wildcard mask in OSPF. If you try entering a network statement without a wildcard mask, it's going to give you an error message. What the network command means is the same as it was in EIGRP. Look for interfaces with an IP address which falls within that range, and then enable OSPF on those interfaces, meaning send out and listen for OSPF hello messages and peer with adjacent OSPF routers. Once the adjacency has been formed, advertise the network and mask which is configured on those interfaces. So the same example as we had before for EIGRP, you see we've got R1 here. Fast Ethernet 0/0 has got IP address 10.1.0.1/24. Fast 1/0 is on the 10.0.1.0/24 network, and Fast 2/0 is on the 10.0.2.0/24 network. So we could put in 3 separate network statements to cover each of the interfaces, or we could just cover them all with just one network statement. Actually, in the example here, we just want to turn on OSPF for interfaces fast 1/0 and 2/0. We don't want to include 0/0. So we configure a network command, network 10.0.0.0, 0.0.255.255 area 0. So all interfaces that have got an IP address that begins with 10.0 and then anything after that, we're going to turn OSPF on for those interfaces. So that will match on interface fast 1/0 and 2/0. Fast 0/0 begins with 10.1, so that is not included in the network statement, so we're not going to turn OSPF on there. The networks that will be advertised are 10.0.1.0/24, because that's the IP address, the subnet configured on interface, and 10.0.2.0/24. We do not advertise 10.0.0.0/16, which is what we configured in the network statement. Okay, the network statement does not say advertise this subnet. The network statement says look for interfaces which fall within this range, enable OSPF on the interfaces, and then advertise the subnet that is configured on that interface. Okay, so that's how we do a basic configuration of OSPF. Moving on to actually verifying it now. To see your OSPF configuration, we can do a show run and then pipe it to section OSPF. That will show all of the OSPF commands in your running config, whether they're under the main OSPF part of the configuration or at the interface level. So this is convenient to see all your OSPF commands. It's easier than doing a show run and trying to scroll down to the actual part of the config. Show IP protocols will show all the routing protocols that are running on the router. You can see in the example here, we're running OSPF with process ID 1. You can see other information like the networks it's routing for, the routing information sources, which are the OSPF neighbors, etc. Show IP OSPF interface brief will show which interfaces have got OSPF enabled on them on this router, the process ID for the interface, the area, the IP address and mask, the cost for the metric, and how many neighbors are reachable through that interface. With the OSPF operations that run in the router after you enable it. So the first thing it does is it discovers neighbors and forms adjacencies. So if you're going to verify that OSPF is working, it makes sense. The first thing to check is that it has been able to form adjacencies. The command to check that is show IP OSPF neighbor. Whenever I configure OSPF, the first command I always do after that, once I've configured both sides of the link, is show IP OSPF neighbor, check that the routers can see each other and they have formed an adjacency. So you see the example here, the neighbor ID is 10.0.2.1 and it's reachable out interface fast Ethernet 0/0. The next thing that happens with OSPF operations is the routers will flood the link state database. To see if routes have been learned from OSPF, you can use the show IP OSPF database command. That will show all the links that are available in that area and throughout the OSPF network. The next thing that happens is the routers will look at all the available possible paths and they will decide which is the best path using the shortest path first algorithm and put that best path into the routing table. So next command to verify is show IP route and check that you've got OSPF routes in the routing table. Again, when I configure OSPF, first command I'll use is show IP OSPF neighbor, check the adjacency has come up. The next command after that I'll use is show IP route and check that OSPF routes are in the routing table. I won't normally look at the database unless the routing table does not contain the routes I was expecting, and then I'll use that more as a troubleshooting command. Okay, so that was how to do a basic configuration of OSPF. In the next lecture, we'll actually do this in the lab. Thanks for watching. If you'd like to get the complete course ad-free right now, then you can enroll in my CCNA Gold Bootcamp by clicking the link above my head or in the description. It also includes full study notes, quizzes, and 150 pages of additional troubleshooting labs you can't find anywhere else.